Hello everyone, I am Chickerur and I will be handling certain sections of this course. This is week 2 and week 2 we will be discussing containerized AI systems. In this session, we will discuss about Docker fundamentals for GPU enabled AI workloads. The idea is to understand as to why containers are the packing units of modern AI and how your code reaches a GPU actually. So, from this session, we'll be able to understand and explain the layered image model and why it matters for multi-gigabyte AI images. We would be able to distinguish between image and containers, what is Dockerfile versus build context, layer versus tags. We'll also be able to describe the CUDA driver, bar toolkit split, and the failure modes it causes. We'll run a GPU backend container and verify the pass-through with NVIDIA SMR. We'll also build a pinned GPU capable image from a Docker file as the hands-on in this particular session. Why are containers so important? There is this reproducibility problem in AI, which basically could be understood like this. Let us say you have a real research stack, you're working on some problem, and you're working with Python 3.12, CUDA 13.0, CUDA 9, PyTorch 2.11, so on and so forth, with certain custom CUDA kernels, which you need specifically for the specific GCC compiler which you want. Now you want to ship it to a collaborator or your other colleague who are working with you on the similar stack or the same stack rather. So when you actually ship it to a collaborator, what effectively happens is in his particular system, he would have a different driver maybe, he would be using different version of the Python, different BLAS, so on and so forth, and basically the code breaks, right? So what effectively happens is that there is lot of reproducibility problem for that specific research stack of yours. CUDA environments do help us with Python, but not actually with the system libraries, the drivers, and the kernels. So one of the things which is that the containers basically is going to freeze the entire user space for us, in a sense that all the OS libraries, the Python files, the framework actually is bundled into one shippable artifact, which we can share it with others, and they also can actually start working immediately without any problems. So from the core concept point of view, we would be working with Dockers basically. And then when we talk of Dockers, we'll be working with containers, images, there will be various layers. So let's try to understand the mental model of what we're trying to work with. We have an image on one hand, we have a container, and we have a layer. So image basically is an immutable layered file system plus certain metadata, which is built once. It can be run anywhere where a compatible runtime exists, right? So an image is an immutable layer file system. And then a container is basically a running or a stopped instance of an image with its own writable layer, namespaces, and C groups. So image is immutable, and then container basically is the instance of that specific image. When you talk of a layer, layer is one file system which is basically there per Docker file step, which is cached and shared between images. Okay, this is very important. We talk of bases wherein you have about 5 to 10 GBs of data in your system. So AI images basically are really very huge. So layer caching and ordering actually is not very nice to have, because that is when it is decided or your system decides as to whether when you have a rebuild, right, will take 30 seconds or 30 minutes. So effectively the mental model wise, if we see, we should understand it like this. We have our own AI model code. It can be PyTorch, it can be TensorFlow, whatever. So we have our PyTorch code. Now that PyTorch code basically will be using the CUDA toolkit, and that CUDA toolkit would be in the container. And then you have NVIDIA container toolkit, which basically is the runtime hook, actually, basically, so as to say, when you are trying to run it on X system or a Y system, so there has to be a connectivity between the container stuff and the runtime. So there is this runtime hook, which is the NVIDIA container toolkit. And then you have the host NVIDIA driver and then the physical GPU. So this is how this is all mapped. I hope it is clear, but as we go along, we will see how actually we go everything into the details of each of this. But we should understand that basically containers per se will not have a GPU hardware, okay, or a GPU driver that's on the existing host. But when you ship, it will have all the CUDA libraries, all the applications, right, and all the other things needed for the program to run on the physical GPU, which is there on the host. Okay. So let's try to understand this in a detail. When you try to run something as a Docker file and you want to run it on a GPU, right? So this would be something like this. You have this from NVIDIA CUDA 13.0 runtime Ubuntu 24.04. So this basically means this is a Docker file which tells we don't have any drivers inside, because drivers would be there on the host system. Okay, and then you have this run apt get update, so on and so forth, which Python you use. What are the requirements? So there is this requirement.text. Then you use pip to install of what is there basically in this, and then you copy that to the workspace, and then you basically try to run your Python file without actually reinstalling PyTorch or whatever, since you are seeing here train.py. Okay, so now let us try to understand the CUDA split, the driver versus the toolkit confusion. So a lot of people, when they start working with the GPUs, right, there is this particular thing of a confusion in terms of the driver as well as the toolkit. So on the host, let us say we have kernel module plus the GPU driver. So for example, 580.xx, it's installed one per machine. It is never inside the image. So this basically means we are talking the kernel module with the GPU driver, okay, which are numbered as 580.xx. This is the versioning style, okay, and it's always installed once per machine. And in the image basically, which you basically try to give it to your collaborators, it will have CUDA toolkit. It will have libraries like kublas, CUDA DNN, NCCL plus various framework, and this basically ships with your container. So from a layman's perspective, let us say the compatibility rule, if we say, is that the driver version must be new enough for the toolkit in the image. So this basically means when you ship your image to other person and he has to use that image as a container, the version of the driver which you have installed, okay, in your host system should be compatible with the image which you are getting from the other person. Otherwise, there will be a mismatch, and then there will be this error which will tell about CUDA driver version is insufficient for CUDA runtime version upgrade. So it will ask you for an upgrade, so on and so forth. So the direction is the host driver, okay, has to be in compatibility with the image which you are trying to run, or we will have to pick an older CUDA base image. So this is what basically it means, right? So this is the distinction between the CUDA driver and the toolkit when we are trying to work on the images and the containers. Okay. So now let's try to understand the NVIDIA container toolkit. That basically means that how is that my GPU going to reach the container, or whatever is there in the container, how is that it goes to the GPU and things are executed in the GPU, right? So let us try to understand this first statement like docker run minus minus GPUs all. So this type of a command is going to trigger the NVIDIA runtime hook, which I told you, okay, to basically see as to how many GPUs exist, and the program or the Docker can run on all the GPUs, right? So Docker will help us to run the programs on all the GPUs, right? Or we will try to say there are two GPUs, for example, device 0 and device 1. Okay, there are two GPUs, so we can say certain specific programs, okay, can be run on GPU 0, which is device 0, and certain programs could be run on GPU device 1, right? So that basically means that Docker actually gives us the control to run our programs on whatever GPUs we like, right? And then the CUDA applications basically see the GPU is installed natively, okay, and the drivers are installed on the system, the host system, and then it basically checks all of the requirements, the reproducibility, and that is how the programs are run on the actual GPU in the on the physical system, right? So now we are talking of the tags, right? So how do we choose a base image deliberately? The basically means that what does base mean? Okay, so base basically means the bare CUDA runtime, the runtime API, which is the smallest, and we can add everything onto it. So it is a minimal kernel type of stuff, if you can correlate it with the Linux OS, right? So it's a very, very minimum base thing, right? The CUDA runtime, the bare minimal CUDA runtime API. When we talk of runtime, you add to this base, right? Kubla, CUDNN, NCCL libraries, and they are basically the right default minimum requirements, okay, for running the frameworks, whatever you want. And when you talk about develop, okay, then we will have to use NVCC and header files, and needed only to compile kernels and build wheels. So the basic idea here, what we want to convey is that based on the application, based on the severity, based on the requirement, right, we can choose our base image very, very cautiously and whatever is needed, okay? Otherwise, it's going to unnecessarily increase the size of our container, okay? So now that basically means that the framework images, that means PyTorch, okay, or something from the NGC, are basically developed, right, for convenience, right, and basically, for easy testing, right? So the basic idea here is the way in which the production environment softwares and things are developed is that you build with, develop, and then deploy on the runtime, right? So this is how basically is to be understood, and we will try to discuss this in session 2 when we talk about the multi-stage stuff, okay, of working with Docker images. Now, from the hands-on perspective, let us try to understand in today's lab, right, how do we verify the GPU pass-through? We will try to understand the host sanity. That means whether our driver is loaded or not, whether we have been able to install the driver which is required by our system or the host system, whether the toolkit is installed at one time per machine. Okay, so we can install it using sudo apt get install NVIDIA container tool. So these are all things which are to be done on your systems, okay, if you have an NVIDIA enabled system. Okay, or you can do it in your labs wherever you have NVIDIA enabled systems. So because you require GPU to work on things like Dockers, okay, and then these are certain steps. So GPU visible inside a container. So you have Docker run command, which we will use it. GPUs all. NVIDIA SMI tells us the status of the NVIDIA GPU which exists. Limit exposure to one GPU. That basically means you can run your Docker container on a specific device, specific GPU. Okay. So once it is all successful, you're able to execute it. The same GPU table is inside the container as on the host. So let us try to understand this in detail. I'll go and tell you the setup which I have set up for doing all the labs in all my sessions. Okay, so today we will go through it. I will show you this particular lab, and then we will do lab 2, wherein we are building and running our first GPU image. Again, it's a step-by-step thing, and then we will actually see this and then on a hello world program type of stuff using Docker run. Okay, so these are two things which we will be doing today in this particular session. All my sessions will have a brief hands-on. Okay, so to start with, I will tell you the setup which I will be using throughout my sessions. So my sessions will have three things. One thing is this VS Code, which basically would be using, which I'd be using, and this is going to be used with all the things which I do in the lab, right? So VS Code is what you should install, and then there is this Docker desktop, okay, which you will have to install. So if you are using Linux, then there is a way of installing Dockers. If you are using Windows, I am intentionally using Windows because I would work with WSL, okay, as well as VS Codes. I want to integrate all of that so that everybody of us would be accustomed to working on WSL, then Docker desktops, Dockers, Kubernetes, because all of this actually requires a lot of integration. So the intention of choosing VS Code, the Docker desktop, Windows operating system, and WSL is to actually tell in totality, like all of these things can be integrated together and used for our labs. Okay, so as we go along, I'll tell you how we start working step by step, but this is the setup which you can do for your systems, right? So there is this Docker desktop which we will be using. We will be using VS Code. I'll be giving you all the programs which I have and which I all will be running. Okay, so week 2, week 3, week 4 programs for all the weeks. Okay, I will be sharing it with you, and there is this readme file which is there, and you can do everything at your own pace. And if you have any doubts, you can please mail us, and we will actually solve all your issues, right? So if you see this, there is this week 2 container, and then today I will be running this 01 minimal GPU, which talks of how basically you are going to create a Docker file. Okay, so this is a minimal GPU enabled PyTorch container. Okay, so this is using CUDA 13.0.0, CUDA CUDNN, runtime Ubuntu 24.04. Okay, so this is that Docker file. Then you are using this GPU smoke test, which basically means that it is just a test to understand which PyTorch version we will be using. Okay, what is the CUDA available on this device, whether CUDA is available or not. Okay, and CUDA is whether available on the system, not available on the container. Okay, so on and so forth. So there are these things which we would be executing today. Okay, so let us start. So as I share the codes with you, so there is this 01 minimal GPU thing. So let us try to run the program with WSL bash run.sh. Since I am using it in PowerShell, I have to give the command WSL before I run that. Otherwise, if you directly run it on a terminal, you should directly use bash run.sh, right? So let us see what happens. So now this is trying to pull whatever is required, okay, as per the Dockerfile requirement, okay, and then it actually is now running the smoke test on the hardware which is on this host, okay, and now this basically means that I am working with, okay, a device 0 which is NVIDIA GeForce RTX 3050, and it's a laptop GPU. It's a compute capability of 8.6. Its total memory is 4.0 GBs. Free memory is 3.2. It has got this particular device. We've got 20 multiprocessors, and I am trying to run a very small compute check on the device. So that is basically a small program, which if you see this program here, okay, it talks of, okay, very compute thing, okay, of trying to do a random, okay, compute, okay, using torch function, okay, and then trying to tell that this particular compute device is okay. So this basically means if the above printed OK is there with you, this one, we have a working GPU container. So this basically means that now we are actually able to generate, okay, a Docker file, okay, which is going to run on the host, and this particular Docker file along with this folder as I am sharing with you, okay, you can use it in your system and try to see, okay, that this program also runs on your system and you get the same result. So this basically is possible only when you have Docker installed on your system, and then the appropriate host has appropriate GPU along with the appropriate NVIDIA GPU driver for it. Okay, if those two conditions are met, this program is going to be successfully running on your system as well. So for this session, we will stop today and we will continue with the next session tomorrow, which will be a detailed session on the Jupyter environment which we would like to create and how do we use it for our own development. Thank you.